LO. Be able to form and solve quadratic equations using the application of conditional probability. Phil the Kettle is about to embark on an adventure. The adventure involves selecting and eating 2 sweets from a bag without replacement. It is far from an exciting adventure. There are 7 toffees and an unknown number of mints in the bag. There are n sweets. The probability that he eats 2 toffees consecutively is 7/12. Work out how many sweets are in the bag. So this is quite a tough question, but the fact that it says he's going to eat 2 sweets without replacement is crucial, and that indicates that it is going to be a conditional probability question. So, if we had 7 toffees and we had 10 sweets in total, it would be easy to assign a probability to the initial pick of toffee, which would be 7/10. However, we have n sweets and 7 toffees, so the probability of picking a toffee is going to be 7/n. Now we're focusing on the probability of eating 2 toffees because we have the probability for that outcome, and it's 7/12. So what we can do is we can look to assign a probability to the second toffee. Now if he's eaten a toffee, then there are only going to be 6 toffees left in the bag. Now, if you had n sweets in the bag before one was eaten, there's now going to be n-1 sweets left in the bag. So now we have the probabilities, albeit algebraically. Now what do we do when we've got a probability tree diagram? Yep, you guessed it. We times along the branches because the song goes as follows. You times along the branches. Oh buddy, would you stay? You times along the branches. Everything's gonna be okay. So remember that song. Great song. Now, we have toffee and then toffee. So we times along the branches. Oh buddy, would you stay? 7/n multiplied by 6/n-1, and we know that that is going to equal 7/12. So there we are. At this point, you're scoring points on the exam question. Now we need to simplify this, and you'll see what happens from this point onwards. So what do we do when we're timesing fractions together? Yep, you guessed it. We fnyam across the top, we fnyam across the bottom. By that, I mean we times across the top and we times across the bottom. Now, it's worth putting brackets around expressions so that you can see that you're going to be expanding those brackets. We'll skip a step here because n multiplied by n is n squared. N multiplied by -1 is -1n, but we don't write -1n because it's not polite. So in fact we have n squared minus n as our denominator, and then we've got equals 7/12. So again, we're moving forward, getting closer to glory. Now, at this point we can cross multiply. So it's always a good idea to remove the denominators when you're dealing with algebra and trying to resolve equations. So we'll times the left-hand side by 12. 42 times 12 is 504. So you can use a calculator for that, or the brainulator. 10 times 42 is 420. 2 times 42 is 84. Add them together, you get 504. Now, 7 times n squared would give you 7n squared. Again, I could put a bracket around this to times it by 7, but I think we can realize that n squared multiplied by 7 is 7n squared, and minus n multiplied by 7 is minus 7n. So now we're in quadratic territory. Obviously, to solve any quadratic, whether by factorization or by use of the quadratic formula, we need to have equals 0. So I'm going to subtract 504 from both sides, and I'm going to set up my quadratic as follows. Now, obviously at this point you could use the quadratic formula. However, I would do a quick check to see if I can divide 504 by 7, because the first two terms I can definitely divide by 7. So a little jump to bus stop division. 504, and I'm going to put the 7 into the 504 bus. 7 does not go into 5, but it goes into 50 7 times, remainder 1. 7 goes into 14 twice, so therefore, yes, it does divide by 7. It divides to 72. So now we can rewrite our quadratic as n squared minus n minus 72 equals 0. Now, obviously, another thing to factor into your consideration is this number of sweets is going to be a whole number. So therefore, it's likely that we're going to be able to factorize to solve this problem. So we are going to factorize. When I say factorize, you say bractorize. Factorize is always associated with brackets, remember that? So we've got two brackets with n in them. That creates the n squared. Now when you've got a negative on the end, that indicates that it's going to be a plus and a minus within the brackets. So there's a plus and a minus within the brackets. And then we need two factors of 72 that go together to make minus 1n. Obviously that is minus 1n, but we don't write minus 1n because it's not polite. So I'm looking at factors of 72. Now, they're going to have a difference of 1. So the factors of 72 would be 1 and 72, which isn't going to work, 2 and 36, which isn't going to work, 3 and 24, which isn't going to work, 4 and 18, which isn't going to work, 5 doesn't go into it, 6 and 12, no, but 8 and 9, yes. Now obviously to make minus n, it's going to be plus 8 and minus 9. So that's the perfect factorization, and then your solutions are just the opposites of what's in the brackets, because obviously n plus 8 or n minus 9 must equal 0 for two numbers times together to make 0. So therefore the solutions are just the opposite of what's in the brackets. So the number of sweets could be minus 8, or it could be 9. Now obviously the answer is going to be 9, because we can't have minus 8 sweets in a bag. That would be good for nobody. So the number of sweets in the bag is 9. And if you think about it, 7 over 9 multiplied by 6 over 8 becomes 42 over 72, and that simplifies to 7 over 12. So that's how you solve this problem. That's how Phil the Kettle knows how many sweets are in the bag, and that's how you gain a load of marks on your IGCSE paper. Hasta la pizza, arrivederci, so long, goodbye, thank you, and see you next time.